We'll try that again. Polarization by reflection. Unpolarized light can be polarized either partially or totally by reflection. At one particular angle of incidence, called the polarizing angle, the light for which lies in the plane of incidence is not reflected at all, but is completely refracted. So the polarizing angle here, this is Brewster's law. No need to concern yourself with it. I just thought it interesting. So whenever you have water, you will have partially polarized light. Whenever you have a thin sheet of metal, you will have partially polarized light. This stuff does pop up. So how can you completely polarize it? You would have to run it through another polarizer, or perhaps a polarizer and an analyzer. So it just depends on the index of refraction for the second material and the index of refraction for the first material. And that gives you tan theta because of geometry. Like adding vectors over here. When you look, why is the sky blue? Finally, perhaps after 13 years in school, we are answering this question. If you guessed that it's because of the oceans, it is not true. I'm sorry you were taught that. When you look at the daytime sky, the light you see is sunlight that has been absorbed and re-radiated in a variety of directions. This process is called scattering. Rayleigh scattering, to be precise. Light scattered by air molecules contains 15 times as much blue light as red. That's why the sky is blue. It'll make sense in the future slides. Clouds contain a high concentration of suspended water droplets or ice crystals, which scatter light of all wavelengths equally, so the cloud looks white. All right, so in the Earth's atmosphere, we have the sun's rays coming in from space, all the colors coming in as white-looking light. So Roy G. Biv is present. And then as it comes down, the longer wavelengths are going to get through Earth's atmosphere. Meanwhile, the blue higher energy and the violet higher energy light is bounced around. So when we look up into the atmosphere, we're seeing this bouncing around of these blue and purple light. So we have three different types of scattering, really two different types of scattering. We have Rayleigh scattering and we have Mie scattering. Rayleigh scattering is what we just observed, where the light comes in and then it's bounced in all different directions. Some of it comes straight back. Mie scattering happens when there is slightly larger particles. So this is the phenomenon where clouds become visible. So slightly larger, and we have this reflection happening in all these directions with greater intensity on the back side. So on the front side, we're still seeing all of the different colors, but it's going to appear white. For an even larger particle, then we get more condensed reflection happening. So that means less of the sun's rays can get through, so those white clouds begin to appear darker. I think that's it. That's it! Hooray! We've made it through wave behavior. Time for some practice problems.